derivative of a function at a given point of time using limits. So let's start. This is actually Netflix's stock price over the course of today's 8:30 a.m. to 3:30 p.m. We're using a real life example. This is what actually happened today, and we're going to find the rate of change at a given point. Now, I'm not going to actually solve for it because there is no way you can find the function, create a function for this graph. But what I can do is explain how a computer would do it if they wanted to find the rate, because the computer won't actually keep record of every change per second. It's going to calculate that point in real time and give you the answer. So I'm going to explain how a computer does that. So let's first find what point in time you want to find our rate of change. Let's say this point in time right here. I don't know what time this is, but let's say, well, it's hitting a dip. Let's find out what change it was going through. So the instantaneous rate of change is defined as the slope of the tangent line, at a given point x. So let's draw a tangent line. A tangent line is basically a line that slightly touches the function at that point. So let's just imagine that this line right here is barely touching the function at this point, A. Let's call this line A. Now, to find the slope of this tangent line, we're going to have to draw another line. Let's call that H. Right here. This is going to be called H. Now, what we're going to do next is we're going to draw a secant line. A secant line is going to touch the equation, or the function, at that point and connect it to the point A, the function, which is going to be right here. Now we're going to draw another one, but that's much closer to A. This is going to be called our second H, or H2. Let's draw another secant line for this. We're going to start off over here, and it's reaching here. Now, let us compare these two lines. So we've drawn two secant lines, and let's see what's happening. Oh my lord. This is our old secant line, the one that was farther apart. And this is our new secant line. What is happening? What's happening is, as H moves closer and closer to A, the secant line is actually rotating clockwise in this instance. So it was kind of flat over here, but it slowly rotated and rotated as we got closer and closer, like this. And if you want to compare this secant line with this tangent line, you would see that's pretty similar. And the thing is, if you went even closer and closer and closer, you would eventually approach the same tangent line as this. So why are we doing this? So what this equation, or the function, or the formula for slope is defined as change in y over change in x. That is essentially what is happening right here. We're finding the change in y and dividing it by the change in x. So if you do that, you're going to get limit, as the limit h approaches 0, as this line h approaches 0, f of x plus the value of h minus f of x divided by h is the rate of change at that point. So that is literally what's happening right here, where finding the change in y and dividing it by the change in x. And that is instantaneous rate of change.